Hello YouTube, welcome to this video, and today we are going to be proving the arithmetic-geometric mean inequality from the triangle inequality. Alright, and I actually found this unique proof in a book called Linear Algebra for Dummies by Mary Jane Sterling, a rather interestingly titled book to find this incredible proof in. Well, anyway, without further ado, let's get started. So first, we're going to let A and B be positive real numbers. And we're going to let U and V be elements of the space R2. So they're going to be vectors. All right. And now we will let such that U is square root of A, square root of B, and V is defined as square root of B, square root of A as the X and Y components. Alright, now we can get started and we can actually write the triangle inequality. So the magnitude of U plus V is less than or equal to the magnitude of U plus the magnitude of V. Great. Now we can plug in the vectors themselves. So we'll get the magnitude of square root of A plus square root of B, square root of B plus square root of A, square root of A. And that shall be less than or equal to the magnitude of square root of A, square root of B. So many square roots here. And plus magnitude of square root of B, square root of A. And then from this, we can now expand out the magnitude. So we would get square root of A plus square root of B squared plus square root of B plus square root of A squared, all within the square root. And then that should be less than or equal to, and I'll write this down below, square root of A squared plus square root of B squared. All right. And we would basically repeat the same thing another time, right? So we have that for this one here. And you know what? We can easily simplify this, and we can make that equal to 2 times square root of A plus B, right? Great. Now, we can see that the beginning and ending inequalities are equivalent. So now we can square both sides of the inequality. We can square both sides of the inequality, and this is what would happen. So let me square that, and then square that. All right. And then all squared is less than or equal to 2 times square root of A plus B. All squared, excuse me. There we go. And then now it would simplify down to 2 times square root of A plus square root of B squared less than or equal to 4 times A plus B in brackets there. And now we can carry on. We can divide the 2 and the 4, right? So that would become square root of a plus square root of b all squared is less than or equal to 2 times a plus b. And as you can probably see, we're getting very close now. We can expand this guy out here. All right, that's going to become a plus 2 times square root of ab plus b is less than or equal to 2a plus 2b. And that would become, then we can like subtract a and b from each side. So that would become 2 root ab is less than or equal to a plus b. And that finally implies that root ab is less than or equal to a plus b over 2. And there we go. We have proven the AMGM inequality right from the triangle inequality, and surprisingly using vectors. So, well, that was it for this proof, and hope you enjoyed it. It's a rather unique one out there. Usually to prove the AMGM inequality, we use the fact that a plus b all squared is greater than 0, and you start from there and you work your way to this. But I mean, this was a pretty unique route to take. And yep, that's it for this video. I also have another video that's for the standard way of proving this, that I'll release very shortly. So yeah, thank you very much for watching this video, and have a good one. Bye-bye.